Evening to everyone. Last question about mission of lathe, principle of lathe, different types of lathe machines, what are the operations performed on lathe machines, and what are the work holding devices and tool holding devices are used in lathe machine. Next, different types of checks, classification of checks, 3-jar checks and 4-jar checks. Today in this class we will discuss about classification of automatic lathes. When it comes to automatic lathes, two classifications are there. Okay, I will show you in PPT. These are all topics we are covered in last class. Okay, work holding devices, handles, lathe centers, checks, different types of checks, 3-jar checks and 4-jar checks. Next, colored checks, magnetic checks, work holding devices. Spindles, stalk spindles, types of lathe dogs, left hand offset tool holder. Okay. Coming to today, in this class we will discuss about classification of automatic lathes. Already I told you, automatic lathes are classified into two classifieds. That means two classifications. One is semi-automatic lathe and second one is automatic lathe. Today in this class we will see about what is the difference between semi-automatic and automatic. Next, first of all, I will semi classification automatic lathe. What is the basic similarities and what is the difference between semi-automatic to automatic lathe? Okay, the answer implies, when it comes to semi-automatic, that means fully automatic operations are not done by using automatic lathes. Okay, fully automatic operations are not performed in semi-automatic lathes. When it comes to automatic lathes, fully automatic operations are done by using automatic lathes. Okay, that main difference between semi-automatic to semi-automatic is, in semi-automatic, fully automatic operations are not done. In automatic lathes, fully automatic operations are performed by using automatic lathe machines. Okay. What is semi-automatic? Semi means in this not fully operations. That means here some human involvement is also there. Okay, these are also known as production lathes. Or why? Because we are calling production lathe because of here human involvement is used for certain operations. Okay, the basic or main examples for semi-automatic lathe, capstan and turret lathe. Okay, capstan and turret lathe. These are by using semi-automatic lathes, higher production rates are coming. Next, semi-automatic lathes are designed for short continuous runs. That means here previously I was told you the basic or main examples for semi-automatic lathes are capstan and turret lathe. These are used for drilling, countersinking, reaming, tapping like operations. Okay, we will see about what is capstan lathe and what is turret lathe. Okay. First of all, I am discussing about turret lathe. Turret lathe is used for multiple cutting operations. That means at a time we will perform. That means at a time we can do all operations at a time. We can done or we can do multiple operations at a time. Okay, capable of performing multiple cutting operations on the same workpiece. We can done multiple operations like turning, boring, drilling, thread cutting and facing operations at a time by using turret lathe. Turret lathe is also known as versatile lathe machine. Versatile is nothing but it have machine center like 360 degrees rotating machine center is having versatile machining center. Okay, versatile means 360 degrees rotating machining center. Okay, at a time we can do or at a time we can perform certain machining operations of multiple operations. At a time we can perform multiple operations by using turret type lathe machine. This is the example for a turret lathe machine. This is the figure of turret lathe machine. Here in center carriage position I am showing tool center. We can fix of drill bit. Okay, reaming operations, reaming, drilling, tapping, okay, etc. type of operations are performed by using turret lathe machine. It is the schematic diagram or example for capstan lathe. Lathe machines are capable for carrying out multiple cutting operations. In previous slide, I'm discussing about multiple operations of like drilling, reaming, boring, etc. Okay, here it is the example. That means here it is the picture for multiple operations. Okay, previously I was told you it is the machining center. In this I am fixing multiple operations for required operation, required work parts or required work. We are fixing different types of drill bits or machine tools for machining center. Here, first of all, I am fixing drill bit, next reamer and boring machine and drill multi-tooth cutter in this. Okay, why I am fixing all types of machine tools to the machine center? Because of turret lathe is the main principle or main heart of turret lathe is machining center. Okay. By following machine, we call it as versatile lathe machine. Okay, it can rotate about 360 degrees. So why I am calling versatile lathe machine is turret lathe machine, because of only one reason: multiple operation can be done by using one machining center. So I'm calling turret lathe machine is the versatile machine. Several cutting tools are mounted on tetra, penta, hexa on turret, which replaces the tailstock. Okay. Instead of tailstock, we are using machining centers. Okay. These tools can be rapidly brought into action against a workpiece. Okay. We already know about that. The workpiece is fixed at headstock. That means workpiece is holding by using of chuck. Chuck is fixed in spindle of headstock. By opposite to the headstock, we are fixing machine center here. In machine center, we are fixing different types of multiple cutting operations in turret lathe machine. Next, it is the classification of automatic lathes. One is semi-automatic and second one is the automatic. When it comes to semi-automatic, we are discussing about single spindle and multi-spindle. Next, coming to automatic, in this also two classifications are there. One is single spindle and second one is the multiple spindle. Okay. Here we will discuss about automatic lathes. Okay. Automatic lathes. First of all, definition for automatic lathe. That means in which components are machined automatically. Okay. In first slide, I'm discussing about what is the difference between semi to automatic. Okay. Automatic means fully operations. That means feeding, produced part removing, operations done by using machines only. In automatic, fully automatic operations are done by only using machines only. Human involvement is not there in automatic lathe machines. Okay, only operation required to perform manually is loading bar stock. That means loading is only the manpower is required. In loading operation, the manpower is required. After then, it will be controlled by using machining operations. These machines are used when production requirements are too high. That means for other operations, we are using turret lathes. That means semi-automatic lathes for fully production rate. That means where it is heavy, high production rates are there. When demand is very high, then we are preferring automatic lathes. Manual machine controls replaced by various mechanisms. Okay, may have single or multiple spindle. Okay, in automatic lathes, two classifications are there. One is single spindle and second one is the multiple spindle. First of all, I am discussing automatic lathe features. Minimum manpower utilized. That means only in bar stock. That means only in loading operation we are requiring or we are preferring manpower. After that, all are machining operations meant for mass production. Previously, I told you where demand is very high for production, then we are preferring automatic lathes. Okay, mass productions to eliminate amount of skilled labor, horizontal or vertical spindles, more accuracy can be obtained by using automatic lathes are very accurate comparing with semi-automatic lathes. Tool setup is permanent. Only we are changing the directions of moving. X direction, Y direction, Z direction. Okay. Remaining things are same. By using automatic lathes, advantages are greater production over a given period. Okay. Production is very high by using automatic lathes. More economy, improvement in accuracy. Accuracy means perfect dimension. Without any error, the dimensions are very perfect by using automatic lathes. More constant flow of production means breakpoints are not there in automatic operations. During machine operation, operator is free to operate another machine, can inspect completed parts. That means in semi-automatic, human involvement is 50%, then automatic operation is 50%. When it comes to semi, that means when it comes to automatic, the complete operation, that means 90% is can be done by using automatic, then only 10% of loading and unloading, those are the operations can be performed by using human power or manpower. During machine operation operator, that means machine operator is free, then he can check or he can inspect other parts or he can operate other parts. It is the advantage by using automatic lathes. Classification of automatic lathes: single spindle and multi spindle. Okay, first of all, I am discussing about types of single spindle. In single spindle automatic lathes, classifications are there. First of all, I am discussing automatic cutting of machine. It is the one type of classification in single spindle automatic lathe. Here I am showing automatic cutting of machine lathe. It have cross slides, rear cross slide and front cross slides here. In this headstock and tail stock, then between two cross slides, the work part will be fixed in spindle. Work part is fixed to the spindle or chuck. Then by using two cross slides, we are removing or we are machining the required part by using two cross slides. It is the automatic cutting of machine. Next, in this, two crosses are located on bed. One is front side and second one is the rear side. Here we are using cam mechanism. Okay, cams on camshaft actuate movements. Operation will be the required length of work part is fed out with a cam mechanism. Stock is held at color check. That means the work part will be held at check for rotating spindle. Machining can be done by using toes that are held in slides operating in crosswise direction. That means in last slide, I am discussing about in this figure. I will clarify about that doubt. The work part or stock is held at color check. That means in between two cross slides, we are fixing the work part in color check. Then the operation will be by rotating or in this the work part will be rotating by using spindle. Then in crosswise rotation, the work part is rotating in between two cross slides. The cross slides are rotating in crosswise direction. Then machining operations can be done. First one is the automatic cutting of machine. Then single spindle automatic screw mechanism. In single spindle automatic screw mechanism or machine, single spindle automatic screw machine. Here in this similar to lathe machine, normal lathe machine. Here also headstock is there, and instead of tailstock, we are fixing turret and slide mechanism. Cross slide is there and tool slide and camshaft, lead cam. Instead of lead screw, we are fixing camshaft and lead cam here. By following motor, camshaft is rotating. Then following camshaft, carriage will be moved from left to right side. Then work part will be fixed in headstock check. the spindle will be rotating in clockwise or anti-clockwise direction, then machining operation can be done. It is used for producing small screws, that means 12.7 to 60 dia long. Generally, it is also used for production of all sort of small turning parts. It is not preferred for large turning operations, only preferred for small turning operations. Up to 10 different cutting tools can be employed at a one time in tooling of this kind of screw machine. Screw crosslights are also employed for cross feeding tools. It is similar to first type automatic cutting of machine. In this, headstock is stationary and houses the spindle. That means in normal lathe machines, headstock is also rotate. That means in headstock, chuck is fixed, chuck is rotating. In this, headstock is stationary and houses the spindle. Only stationary. Headstock is stationary. Covers the spindle. Bar stock is fixed at collet check and advanced after each piece is finished and cut off. All movements of machine units are actuated by cams. Okay? In this, all operations are performed by following only cam mechanisms. Cam mechanism and lead cam. Then third one is Swiss type automatic screw or sliding head screw lathe machine. In this, as a per name implies, the machine headstock is movable and tools are fixed. Okay, here I am showing. In this also headstock is fixed, then tools are moving. Okay, only headstock is fixed, then tools are headstock is movable, then tools are fixed. Here, similar to type screw type automatic lathe, single spindle automatic lathe machine. This type is also similar to second one. In this also we are using camshaft and tool cams. Special attachment is a turret type lathe and arrangements. Sliding headstock. Here headstock is moving. Tool bracket, that means tool is fixed at one point, then headstock is movable or translating from left to right directions. Tools are fixed. Bar stock is held at collet check and headstock is moving. Rotating bar stock is fed through hard bushing in center of tool head. That means here only the principle is in normal headstock is movable and tailstock is fixed. That means headstock is known as tail center and tail dead center. Here also same, but compared to normal lathe machines, here the headstock is movable. Total headstock is movable. Then okay, tool center is movable from left to right for our requirement. Then here headstock is moving. Headstock from left to right our requirement. Then tools are fixed at one point. Tool head consists of 5 single points. Tools is placed radially around bushing. Okay, it is the this type single spindle automatic. Next, second classification is multiple type or multi-spindle automatic type lathe machines. What is the difference between single spindle to multi-spindle? That means in single spindle we are using single spindle for machining. In multi-spindle we are using 2, 4, 5, 6, 8 spindles at a time. Why we are preferring multiple spindles? For because of higher production rates are there, we are preferring multi-spindle automatic machine. In contrast with the single spindle machines where one turret phase or one turret phase at a time is working on one spindle. In multi-spindle, all turret phases working on spindles at a time. What is the difference between single spindle to multi-spindle? That means in single spindle we are using only single spindle. That means only one phase are working. When it comes to multiple or multi-spindle automatic lathe machine, all spindles, that means all turret phases are working at a time, at a point. Production capacity is very high and accuracy is lower compared to single spindle. Why? Because accuracy is lesser than single spindle. Because of in single spindle we are performing only one work. That means only one spindle is rotating about machine center. When it comes to multi-spindle, 2, 4, 5, 6, 8, up to 8 spindles, the work is going on. So accuracy, that means small dimensional errors are there in multiple spindle. Because of longer setup time and increasing tooling cost, machines are less economical than other short runs. First one is the parallel action automatics and multiple flow. Here I am showing different types of multiple spindles here. Here I am showing 4 spindles, front tool side and rear tool side. Parallel action, that means parallel work going on by using this type of multiple spindles. In this multiple operation, that means drilling, reaming, tapping, shaping, only 4 types of operations performed at a time by using parallel action. That means similar actions are performed at a time by using parallel action automatics. It means that number of components being machined equal to number of spindles in machine. Okay, it is justified by using number of components machined by using of number of spindles at a time. Here we are using 4 spindles, then 4 types of components are produced. One is drilled, one is bored, one is tapped, and one is reamed. By using different types of spindles, 4 spindles. Machine consists of frame with headstock at right end. Okay. In this type, machine same operations are performed on each spindle. Workpiece is finished in each spindle in working cycle. Okay. 6 spindle progressive action multi-spindle. It is also called as versatile spindle or versatile machining center. In this 6 spindle progressive action automatic lathe machine, here I am showing 6 types of spindles are there fixed in machining center. 1, 2, 3, 4, 5, 6. Okay. 6 types of spindles are there. For 6 spindles, here 6 tool holders are there for fixing tools. By using 6 spindle progressive action multi-spindle, the production rates are very high. That means mass production can be obtained by using 6 spindle. Okay, all operations can be done by using 6 spindle at a time. It is the advantage of 6 spindle progressive action multi-spindle lathe machine. In this, headstock is mounted on left end of base of the machine. Working spindles are mounted on the spindle carriers. Bar stock is fed through spindle from rear side. Number of slides equal to number of spindles. Okay, it is justified by using this equation. Number of slides equal to number of spindles. Okay, number of components can be measured by using number of spindles. Main tool slide extends from middle of the support. Okay, stock moves around the circle. That means here the machining center can be rotated in 360 when based on requirement. Here, first of all, I want to drill the work part. I want to drill the workpiece. So I'm using second one. Second one is in second spindle. I'm fixing drill bit here. So for the requirement, based on the requirement, I'm using second one, second tool holder or second spindle for drilling operation. Then automatically for reaming operation, I'm preferring third one. For tapping, I'm preferring 5. It is the procedure or it is the sequence of operations by using 6 spindle actions. It is the tool layout. By using tool layout, we are fixing or we are calculating the cam operations. Headstock will be fixed on left side. Then the machining center or tool position layouts are fixed by using tool layout operations. 2 to 5, 1 to 4, and 3 to 6. That is the tool layout. In this, second one and fifth one, those are parallel to each other. 3 and 6 are parallel to each other, and 1 and 4 are parallel to each other. It is the direction or position fixed to each other. Tool layout, predetermined plan for order and method of machining operations necessary to produce it. That means here we are following some sequence by fixing of tools to the tool center or machining center by using of tool layout. Choose the best available machine taking into consideration the availability as well as economic manufacture of the component. That means first of all, we are taking the machine for necessity. Based on necessity, we are taking operations. Choose the available standard tooling as far possible. Check the movement and calculate the spacing required for cam periphery. Draw the tool layout. Okay. In this, we are following some procedure here. First of all, taking machine based on the requirement. Next, sequence of operations. Choose available standard toolings. Surface. In case of heavy jobs, we are preferring spindle of power. The machine may be verified. Next, movement of each tool and overlap operations arrangement. That means adjustment of overlap operations. Next, compute process timing for each operations, including ideal time and total time. Next, calculating the space required for cam periphery. After that, final we are drawing the tool layout. It is the procedure for drawing tool layout, following on basic steps on procedure. Machining calculations. Machining calculations for turning is single speed n equal to v by pi into d naught. D naught is nothing but outer dia. V is cutting speed in RPM. Feed rate. Feed rate FR equal to n into F. N is speed, F is feed rate per 1 revolution. Depth of cut D equal to D naught minus DF by 2. D naught is outer diameter. DF is depth final diameter. Machining time is Tm. Okay, MRR is nothing but material or metal removal rate, VFD. V is velocity cutting or cutting speed. F is speed per revolution. D is the dia. Okay, thank you.